Here we're going to talk about the
In
technical
this
meaning
sample
of
calculation,
power.
we're going
I
to
don't
find
mean
the work
power
done
over the
by a
This is the
spring
office hours
or
video
force
for
is a better way
I
of
section
putting it.
4.
The
As we
power
move a
geometry.
package
symbol
attached
P
to the free end of the spring
is an
from
amount of
x
work.
equals 0 to x
Now,
equals
one thing that
17
some people get
millimeters.
confused about is
Or
the difference
in general
between
terms,
Now, the x
an
equals
amount of
0 area and
is
cross-sectional
set to the
area.
position of
For
the
So,
example,
as an
splint
example
I
of
might
that, I
do
thought I
heavy
would
lifting.
look at a
length of the
cylinder.
spring.
And in
No
20
compression,
seconds,
So here's a
I
cylinder.
might
You might think of it as a
spin,
We're
can,
given
use
some information about the
surface of a
spring.
can.
We're told
And,
that
500 joules
if
of
we
energy.
move
let's
the
compare
package to this
the
point, x equals
my
12
average
surface
power
area with the
during
cross-sectional
that
area.
interval
So
of
first of all,
seconds
if I look at the
going to
surface
be
area of this object,
to hold the package there.
it actually has 3
now,
surfaces.
there may be bursts
Well,
of lifting
so
in there.
what I'm
the
going to do is
calculation
kind
of
of
the work
lax
we want
add
to
the
work
areas
on
the
and
average
move
of all
the
3
package.
surfaces
We're not
together.
quite sure how to use
Per
this
second.
other information
It's
just
joules per second.
There are 2
occurs
ends,
so
the key idea here.
and then there's the
in
curved part.
science
Work
and
done by a
engineering.
spring
So,
given its own
the area of
symbol.
each end is going to be pi r squared,
given
which is
by
the area of a
a
circle.
watt.
this formula.
Well, that's
From the
Then I
average
need to add to
power.
that the area of
I
the curved
could
part.
be talking about
The way you can think of that is to think of
R for short.
the circumference of a
position
circle,
the power.
and then
Minus
stretching
If
that
I'm talking
circumference
about
of
the
a circle
power
down the
output
length
of a car,
of the
Usually
I'm
cylinder.
talking about at any
So the
given
circumference of a
moment
circle is
during
2 pi
my
r.
driving.
Final minus
The car's
initial,
power
because
And
of
you
final
multiply
minus
that
signs
by the
going
length
on
of
in
the
the
cylinder.
calculation
some
here.
number in
We've got
watts.
just the reverse.
Now what I want to do is
We're going to use
simplify this as much as
to
possible.
calculate the work
I'll give the
done.
surface area the
General.
symbol A.
Position is
You're
going
talking
to be
about
x
the
equals 0,
instantaneous
and
power.
If I add
final
the
position
You
is
want to
gonna
know the
two
rate at which
areas
the
of
work
the
is
ends
being
together,
done
that's 2 pi r
just
squared.
in that
But there's
instant.
a little hitch.
For example,
you see,
And
I
then,
give
to make
you
this
a function.
easiest
Okay.
to use, I'm going to
It's not
factor all the
given
common
here.
terms out.
35 times
How are we
t
gonna
equals
So,
find K?
here's the final
Second.
And
expression.
that's where this other
And
2 times
information
pi
comes
times
into
the
play.
radius,
We need to
and then
apply
what's left is
in
the radius
packages
plus the
here,
And
length.
if I wanted
force
the
to the right.
power,
So that would be the area
Take
of the surface of the
Order
cylinder.
to
of that
And
offset
that area
the
is
force from
the
the
boundary
spring, which
between
must
the
be
object,
the
the
opposite
cylinder,
direction,
and its
hence
environment.
negative 4.
Now if I take that
the power.
cylinder and
we
slice
can
through
find the
it,
spring
then
constant from that
Here's
information.
one more thing.
I would be measuring the
we can write
cross-sectional
down
area.
F equals
So imagine that this
minus
is,
The
K
work I'm doing
times
oh, I don't know,
could be because
position,
I'm applying a
and it's
force
gonna
to
be
something.
12
Let's make it a
millimeters.
block.
a loaf of bologna. And I
And
take a knife,
let's say I'm
and I cut
pulling on
through
the
it.
block
And
with a
let's say I
certain
cut
apparently
through it
the
this way.
spring
force at an
chop right
angle
down
of
through the middle.
30
at that
degrees.
position,
something
when I
like
do
the
that,
spring is elongated
get
the
by
work
that
I do
arc.
else,
The
and
spring
two
provides
smaller
a force of
cylinders.
pull the block
4.9
through some
newtons.
distance called
We can
x.
solve for K. In fact,
And so the
work that I do
cross-sectional area
is
would be
actually
the
F.
new areas that's
Well,
exposed.
it's not my
K
full
is
F
Now really,
because
in
I'm
this case, there are
pulling
2 of
perhaps
those. I'm not going to
foolishly.
double count
now
them. I'm
we'll
just
go
going to
after
count
the
them
work
once.
I could do
and
better
moving
So
the
the
package
cross-sectional
directly
area in
right,
this case,
17
if I
millimeters.
slice
direction
it
of
We're going to be plugging
displacement,
into
but
that
I'm
formula.
going to stick
perpendicular
with
to
my
the length,
going to be
foolishness.
I'll write it down again.
then that
Here's the
cross-sectional area
component
is
position
just
pull
the area
that
of a
happens
circle.
to be along the
And again, I'm
axis.
not going to double
This is
count.
the component that
I'm not
actually
going to
Zero
count
for
both
the
of those
initial
circles, just
position.
one of them.
And
Final
if I pull
position
through
The
is
cross-sectional
minus
area would be
17
pi r
amount of work I
squared.
do
You can
is
see that's different than the
my
surface
force
area.
component
K we
So I use
just
the
by
symbol for that.
displacement.
Unfortunately, a lot of times we use the
Here's
same
the
symbol,
numbers
A,
expressed
for area.
tight
So you have to know from the
rate
context
at which I'm
fashion
doing
instead of
what the
my
symbol is
surface.
standing for,
We
surface
find
area
that
or
for
cross-sectional
that
area.
displacement, the
derivative
spring
of
does
Now what would
this
happen if
much
we took
work.
the same
Negative
force is not
0.059
changing with
slab
time.
of
joules.
bologna,
It's only the distance
instead of,
that's changing with
We got the
time.
package
cutting
all the
it
way over there at
perpendicular to
17
the length,
millimeters.
angle.
And now we're going to
So when I
move
cut
it
it across the
to
middle like
the
this.
other side
That's
of the
right,
0 mark
front stuff
to
down,
x equal
and
So
negative
if you
12.
cut through it like that, let's say it's exactly through the middle.
Again, we want to know how much work
wait
what
a
you
little
would
bit
get,
longer, and I
the
lose
surface
block
that
a
would
little
be
bit
force
farther.
on the package
along
during
If I look at it
this
from the top,
displacement.
Well,
would be a
dxdt,
rectangle like
however,
this.
Well,
is
we're going to use the same
velocity.
formula.
Oops.
It's
So
going to be
power
work is equal
is
to
F
the work done by the spring is
cosine
going to be equal
phi.
to
So
1/2
the cross-sectional area
K
depends on how you
X
slice
I
it,
squared
which way
minus
you
1/2 K
cut the object.
X sub F
So
squared.
in this
Getting
case,
trig
We're
functions
going to
we
put
get
the
a
numbers in.
rectangle,
The initial
and
position
Oh,
this
and
time
look,
is
uh,
17.
That's just a
This
long way of
rectangle
writing out
of
a dot product.
cylinder.
17
And
times
then
10 to
The
the
dot
minus
product
3
sides,
meters.
that's the diameter of the
The
circle,
final
which
position
is
is
the
going to
same
be
as
negative
force vector
12
dotted
millimeters.
into the
Reexpressed
velocity
as
vector
meters.
r.
So in this
My
case,
sign will,
really
of course,
doesn't make a
disappear
difference
because
which
we're
way you're
squaring that
direction,
coordinate.
on a dot product.
the
What we'll get
cross-sectional
out is
area
positive
comes out to be
point
So this is another way that I
0.03
could
multiplied by L.
write down
30
the
millimeters.
instantaneous
if I wanted to
power, if I
express that
happen
in
to
terms
know
of radius,
This is
the
how much
velocity
work
the
the
vector
spring
diameter
has
is,
done, and this
the
time
twice
that
that,
work
yes.
is positive.
Now, let me
And the
give you
question
a
here
cross-sectional
is,
area would be
why is it
2 times the
positive
radius
when
times the
suppose
length.
I am
package
pulling
out
at angle
So it's important to
phi,
recognize
let's
the
make
difference
phi,
between
the spring did
surface
negative
area and
work.
cross-sectional
We
area.
did
This will become
positive
very
work.
important
So
later
there's
on
the
when
F
we
vector.
start talking
And
about
How
phi
come the
is
spring
now
is
how
doing
0.
positive
energy
work?
moves from one place
Can
to
you
another
see
because
that
of
when
the
the
I will
temperature
spring
do,
difference.
brought the package
I will
up
have
from
the
7
most
Kind of energy is
power
called
to
heat,
0?
because
and
Did
the
a
amount of heat that
fairly
the
flows
large
angle in
amount
this
of
in various
positive
cases
work.
will
here
depend on
is
It
now
will
going
do
to be
one of
a
these kinds of
small
areas.
amount of
now
negative
going
work.
to be
So
0
it's a good idea
degrees,
to
The
distinguish,
compression
in which
from
case
x
I get a
equals 0
cosine of
to
0, which is
negative
1.
12.
and I
I will
recommend
get
that you
the
go through the
greatest
same
power.
procedure for
A
other
large
shapes,
amount of positive
for
What do I
work.
example,
get if
spheres
I
Negative work.
and
pull
cubes,
Overall,
at an angle
positive
shapes
amount
like that.
of work.
9
'cause
degrees?
And
that'll
that's
be
Block
it
is
useful later
moving,
on.
for
sliding.
this video.
So go
Somehow
ahead and
it
try
was
that
already
out,
made to slide, and now
and we'll
I'm
see you
pulling
later on.
upward. Not enough to lift the block. It's still sliding across the floor. Can you see that this is, shall we coin a phrase, stupid? Because if I put in 90 degrees right there, cosine of 90 is 0. I'm pulling up for nothing. The power that I'm using to move the block is 0. I may be straining muscles, but I'm not going to be making the block go faster or slower. Now, for 0 degrees, I had the most power I could get with the given amount of force, and so I would be making the block go faster and faster and faster. I'm adding energy to the block. I'm adding nothing, no energy to the block here. And one more case, block's still sliding to the right, but I'm pulling to the left. So the angle between the displacement vector, still x to the right, and the F vector, well, that's going to be 180 degrees. Can you see that when I put this in, I get -1? I will be removing energy from the block. I'll be making it go slower and slower. The power that I'm applying to the block is now a negative number because I'm taking energy away. Let's do a little quick summary of ideas here. Power is the ratio of work to time. Average power, you're averaging the amount of work being done over a time interval, 30 seconds, an hour, a day, something like that. But you could be worried about the power at a given instant, instantaneous power. That's the rate at which work is being done just then. We can also write power, the instantaneous power, as the dot product of the applied force and the velocity of the object just then. And this is the way we can expand a dot product. Magnitude of F, magnitude of V, cosine of the angle between those two vectors and the dot product. And that's it for this little video.